Hello everyone. In this video, I'm gonna discuss the multiple choice paper 1 of AS level CAE. Okay, so this is the variant 2. In the previous video, I discussed the variant 1. So the first question is: a stone sinks in water. What is the possible value for the density of the stone? So we know that if an object sinks in water, the density of that object must be greater than the density of water. So the more denser objects will sink to that medium. If that object is having less density than of the liquid it is in, it will float, right? So here the stone sinks, which means that it is having a greater density than of this water. So we need to know the density of water, which is 10 to the power 3 kg per meter cube. So in this, out of these options C and D are wrong because the units given are wrong. The unit of density is kg per meter cube. As the density equation is mass per volume, it will be having kilogram per meter cube of unit, and we can conclude it will be the A or B option. And the thing is, the stone sinks, which means that it is having a density greater than this density of water. So the density of water is 10 to the power 3, so the stone must be having a greater value. So it will be only 2 times 10 to the power 3 kg per meter cube, which means that the option B is the correct answer for this question. The second question is: gigameter, terameter, micrometer and picometer are all units of length. Which unit is the largest and which unit is the smallest? So we have the prefixes of the multiples. Okay, so these are the prefixes that we have. So here you know that the highest value is for tera, 10 to the power 12. So it's T. So the largest unit is terameter out of these units of length, right? So the smallest one is 10 to the power minus 12, which is pico. Here the smallest one is picometer. So the correct option is option D. Question number 3. Two measurements for a solid sphere are shown. Mass is equal to 32.5 plus or minus 0.1 gram. Diameter 1.87 plus or minus 0.04 centimeter. These values are used to determine the density of the sphere. What is the percentage uncertainty in the density? So we have the density formula, that is rho is equal to mass divided by the volume. Okay, so here it is given, it is a solid sphere. So if you have the diameter, what you need to do? You need to find out the radius, that is half of the diameter, and the volume will be, it's a sphere, right? So 4 pi 3 pi r cube is the volume of a sphere. So you can use this formula. So the density formula would be mass divided by 4 pi 3 pi d cube, 2 cube, which is 8. So to find out the percentage uncertainty of density, you need to add the percentage uncertainty of mass and 3 times the percentage uncertainty of the diameter, because here the reason for the percentage uncertainty in the density is because of the mass and because of the diameter only. And the diameter is cube, right? It is raised to 3, so you need to multiply the percentage uncertainty of diameter by 3. The other quantities, 4 by 3 pi divided by 8, these are constants, so it won't be having any uncertainty, so you don't need to consider about this constants. Okay, so what you need to find is the percentage uncertainty of mass and the diameter and do the calculation. To find out the percentage uncertainty, what you need to do is you need to find out the ratio of the uncertainty and the measured value. So the formula is uncertainty divided by the measured value, and you need to find multiply it by 100 to find the percentage. Okay, so in the case of mass, 32.5 is the measured value and 0.1 is the uncertainty, which means that this value could be 32.4 or 32.6. it will be around that these values. Okay, so you can substitute 0.1 divided by 32.5 times 100. So you will be getting a value of 0.307. So this is the percentage uncertainty in mass. Then the percentage uncertainty in the diameter is 0.04 divided by 1.87 times 100. So you will be getting a value of 2.14. So you can substitute into the density of this formula, then percentage uncertainty of density formula. So it is 0.307 plus 3 times 2.14. So the value would be 6.724, which means that the option D is the correct answer for this. Question number 4. An aircraft travels along a horizontal path. Two of the forces that act horizontally on the aircraft are the thrust force of the engines and the force due to wind. The vector diagram for these forces is shown. So the directions are also shown in this vector diagram. Okay, which vector represents the resultant horizontal force acting on the aircraft due to these two forces? So you may find out that this question is based on the vector addition. So we have like two methods to add the vectors. One is the triangular method and another one is the parallelogram method. So in the case of triangular method, you can add like this. This is one vector and it's a head to tail method, right? You can add these the second vector like this. Okay, to the head, just add the tail and attach from the starting position to the end. So it will be this vector representing the resultant vector of these two vectors. Okay, this is one method because here it is forming a triangular to find out the resultant vector. It is named as triangular method of vector addition. Otherwise, you can join the two tails of these vectors and form a parallelogram. Okay, so here this is a parallel line for the vector B and this is a parallel line for the vector A. So in this case, the use of parallelogram method would be easier than the triangular method. Okay, so if you are forming a parallelogram using the vectors, just start a vector which is starting from the joining of the two tails of the vectors to the other end of or the diagonal of the parallelogram is representing the resultant vector. Okay, so here is also you could form a parallel line for this force due to wind. Then here you can draw a parallel line for the thrust force of the engines. Please join these two lines and you may find out like this is the diagonal for the vector, and just be careful to start the vector from the joining of these two tails of vectors and end on the other side. Okay, so this is one of the method to find out the resultant force. Which one resembles this? The option C is the correct answer for this question. Question number 5. A ball travels from point X to point Y around a semicircular track of radius 1.0 meter. As shown, what is the displacement of the balls from X to Y? So what you know is the difference between the distance and the displacement. So displacement is the vector that points from an object's initial position to the final position. It is a straight line connecting from the initial to final. So you know that the journey is starting from X and ends on Y, which means that the displacement vector is the straight line between these two, right? So here you know this is a semicircular track, which means that this radius is 1.0 meter. Here there is twice the radius value, so it is 2 meter. So 2 meter would be the displacement, so it could be either A or B. And the thing is, displacement is a vector quantity which is having direction, right? So in which direction it is pointing? From X to Y, which means that to the south. So the option B is the correct answer for this question number 5. Question number 6. A rock is launched vertically upward from the surface of the earth, and an identical rock is launched vertically upwards from the surface of Mars. Each rock has launched with an initial velocity of 12 meters per second. Each rock then reaches its maximum height above the surface before returning back down to the surface. The velocity time graph for each rock is shown. In both cases, air resistance is negligible. What is the difference in the maximum height of the two rocks? So in this case, what you know is, if an object is thrown on earth, it will move, it's launched vertically upward, reaching a maximum height, and it returns back, right? So when it is moving upward, the velocity, you could take it as positive, and when it is returning, the velocity is negative, and at the maximum height, the vertical velocity would be 0, right? So you could find out the launched velocity and the velocity at the maximum height and the velocity after reaching earth, right? So you could find out that the object has reached the maximum height at this time, right? So the area under the velocity time graph is representing the displacement. So this displacement, if you're finding this displacement, that would be the displacement to the maximum height. So this is giving you the maximum height value. So you could find out that it is a triangle. So the area of a triangle is half times the base times height, right? So for the first one, for on earth, the displacement of the rock or the maximum height is 0.5 multiplied by the base, which is 1.2 multiplied by 12, which is equal to 7.2 meter. Okay, so this is the maximum displacement. And in the case of Mars, the area would be this area of triangle. So in that case, it will be half multiplied by the height is 12, and the base is it is 3.2. So 3.2, which is equal to 19.2 meter. You want to find out the difference between these two, which is 19.2 minus 7.2, which is equal to 12 meter. So the option A is the correct answer. Question number 7. Which statement describes the mass of an object? So what you know is, the mass of an object quantifies its inertia. Inertia is the resistance to change in motion. So if you are moving on a vehicle, okay, if you are sitting on a car, so why you are using your seat belt? Okay, car's seat belts is because when it is braking, suddenly you have an urge to move forward, right? Because your body was in a motion, right? So if the brake is applied, it is stops, okay, which means that changes its motion. Previously it was moving. When it applies brake, it is changes its motion, but your body is continues to move forward. That's why when suddenly the brake applies, you're moving forward and eventually stops. So that resistance for the change of motion, or you could say for an object to change its position, or for it to move, you need to apply a force. If there is no forces present, you will continue to be in the same position or continues to be in motion. That's why you need to apply a force to move your book on the table, right? So the correct answer for the question would be option C, the resistance of that object to changes its motion. To changes in motion. Question number 8. A submarine of total mass 3,200 kilogram is at rest underwater. The total mass of the submarine is suddenly decreased by 200 kilogram by pumping water out of the submarine horizontally in a negligible time. The upthrust acting on the submarine is unchanged. The change in the total weight of the submarine causes it to accelerate vertically upwards. What is the initial upwards acceleration of the submarine? So we know that any object would be having a weight which is a force downward, right? And if an object is in water or in a liquid, it will be experiencing an upward force called upthrust as well. So here the upthrust value is the same. So if there is a change in that total weight, that is causing it to move upward direction. The hint is already given. So you need to find out that change in the weight. So weight formula is mass times acceleration due to gravity. So the hint is already given. The change in the total weight of the submarine is causing the acceleration upward, right? So the force formula is mass times acceleration. So the reason for that force is the weight change, which means that change in the mass multiplied by g, the acceleration due to gravity, is equal to mass times acceleration, and you need to find out this acceleration. So the change in the mass is given as 200 multiplied by g value is 9.81, that is equal to the force on this the submarine, right? So it is after the change in the total mass, which means that it has decreased 200 kg from 3200. So the mass of the submarine now would be 3000 only, which is to be noted. So A value is 200 multiplied by 9.81 divided by 3000. So if you're doing the calculation, you'll be getting the value as 0.654 meter per second square. So option B is the answer for this question. Question number 9. Box in air slides with increasing speed down a rough slope from point P to point Q. The slope surface exerts constant frictional force on the box. As the box moves from P to Q, there are changes to the magnitude of its acceleration and the total resistive forces acting on it. Which row describes the changes? So you need to find out the changes in the magnitude of acceleration and magnitude of the total resistive force. So the total resistive force in this case would be the sum of the frictional force. Here is a constant frictional force acting on it. So it would be the sum of frictional force and the air resistance, because it's moving on air, right? There's a presence of air, so you can't neglect the air resistance here. And you know that the air resistance is having a property that if the speed is increases, the air resistance also be increases. Here it is given the frictional force is a constant. So the total resistance would be due to the air resistance and the frictional forces, which is a constant, right? And the air resistance. It is given in the question that the speed is increases, which means that the air resistance also increases, which increases the total resistive forces. So the magnitude of the total resistive forces would be increasing always. So it would be option C or D. Then what will be the magnitude of acceleration? If the total resistive forces is increases, resistive forces is which is opposing its motion, right? If it is sliding downward, the resistive forces would be upward, right, in the opposite direction. So if that value is increasing, obviously the acceleration would be decreases, which means that the option D is the correct answer. Question number 10. Two balls X and Y approach each other along the same straight line and collide. The collision is perfectly elastic. Their initial speeds are ux and uy respectively. After the collision, they move apart with speeds vx and vy respectively. Their directions are shown. Which equation is correct? Here you can use two methods like the conservation of momenta and the conservation of kinetic energy. Since it is a perfectly elastic case, the conservation of kinetic energy is applicable, right? You can't use this momentum conservation because it will confuse you more. So we can use the kinetic energy conservation, which is kinetic energy before collision would be equal to kinetic energy after collision. So both the objects are moving towards each other basically. So the kinetic energy, which is a scalar quantity, and it is a square of the vector quantity as well, right? So it will be mass ux square plus half muy square, which is equal to half mvx square plus half mvy square. So half m is common in these cases, so it will be ux square plus uy square is equal to vx square plus vy square. So you can take the square root of the whole equation. You will be getting ux plus uy, which is equal to vx plus vy. So the option A is the answer for this. Question number 11. A rod is pivoted at point O. A force F is applied to the rod at point W as shown. What is the moment of the force about O? So this is the pivot. So the moment of the force formula is the multiplication of the magnitude of the force and the perpendicular distance of the line of action of force from the point. So this is the pivot. So the perpendicular distance from the line of action, the force is acting on this direction, so this is the line of action. So the perpendicular distance between these two is this OY. So the option B would be the correct answer for this question. Question number 12. A uniform rod XY of weight 10.0 Newton is freely hinged to a wall at X. It is held horizontal by a force F acting from Y at an angle of 30 degrees to the horizontal as shown. What is the value of F? Since it is given that it is a uniform rod, the weight will be acting just the middle of this uniform rod, okay? Which means that the distance from this point to this point of action of weight and from this point to the other end would be the same. You can choose as X. Both this distance would be X. The total length of this uniform rod as 2X. So you know that it is in equilibrium. So in equilibrium, the moment of the forces would be the same. right? So the first force you could choose is the weight of this rod, which is 10 multiplied by the perpendicular distance between the line of force and the pivot. Here it is the pivot, right? So this distance, which we have chosen as x, is equal to, then the next force is the force, this horizontal force F multiplied by the perpendicular distance between the line of force and the pivot, right? So this is the perpendicular distance. This is the distance what we need to take. So if you want to find out this distance, what you need to consider is this triangle. To find out this one, you can choose sine 30 value. Sine 30 is opposite divided by hypotenuse. So opposite side is this xx. You can choose this one as xx length divided by hypotenuse. Hypotenuse would be this whole length, that is 2x. So xf is equal to 2x multiplied by sine 30. Since sine 30 is half, it would be 2x divided by 2, which is equal to x. So here you could write x. So in this equation, x and xs is the common factor on both the sides, which gives you the value of x as 10 Newton. So the option C is the answer. Question number 13. Two solid cubes x and y are made of material of the same density. Cube x has twice the mass of cube y. Cube s has sides of length x. Cube y has the sides of length small letter y. What is the ratio of x and y? Small letters, the length, ratio of the lengths is basically. Here it is given, you need to consider the cube. So volume of a cube is x cube if you are considering x as one of the length, or a cube. So a is the one of the length of this cube, right? So in this case you have two cube, right? X and y. So in this case of x, the length is x, small letter x, which means that the volume is x cube. In this case of cube y, the volume would be y cube. And one more data given is the mass of this x. Mass of this x is twice the mass of y. Twice the mass of y. And the other thing is the same density. So the density of x is equal to the density of y. And the density formula is mass divided by volume. Mass of x divided by volume of x, and my divided by v. So here you can choose like this. The mass of this y could be taken as m itself. So here it would be 2m divided by x cube, which is equal to m divided by y cube, right? So please rearrange this formula to find out x cube divided by y cube, which is equal to 2m divided by m. So m and m get cancelled, which will give you the value of 2. So x divided by v would be 2 to the power of 1 by 3, which is equal to 1.26. So the ratio is 1.26. So the option A is the correct answer. Question number 14. A U-shaped glass tube contains a liquid of density 2000 kg per meter cube as shown. What is the difference in pressure due to the liquid between levels P and Q? So the formula is this one. The pressure difference is equal to rho GH. So the density, which is 2000, multiplied by the gravity 9.81, multiplied by the height difference. This length is 10 centimeter, and the length to the point Q is 6 centimeter, which means that the height difference between these two is 4 centimeters. So here before you are applying to this, please convert into meter. which will give you the value as 7484.8, the pressure value Pascal, which was really close to this. This is the option A. So for the question number 14, option A is the answer. Question number 15. A steam turbine is used to drive a generator. Okay, the input power to the turbine is Pi and the output power is Po. The power loss of in the turbine is PL as shown. What is the efficiency of the turbine? The efficiency formula in terms of power is the ratio of output power to the input power. So you could write in terms of energy too, the output energy divided by input energy, or in terms of work, output work divided by input work, or not output work, you could use useful work divided by input work. Okay, so here since it is given in terms of power, we are using this formula. So here you need to find out the efficiency of turbine. So in the case of turbine, the output power is Po divided by the input power is Pi. So it's a direct question. The option D is the answer. Question number 16. A variable force is applied to ensure that a constant power is applied to a train. Which graph best shows the variation of the force F applied to the velocity V of the train? So here the power value is constant, and you need to find out the relationship between F and V. So what we can do is just take the power formula, which is equal to the work done per unit time. Work done formula is force multiplied by the distance, right, divided by time. Since it is having a variable force, you can take this out and just do the separation. So you will be getting as force multiplied by d over t, which is distance divided by time, which is speed. So the power is having another formula in terms of force and the velocity. P is equal to F times V. So since this power is constant, to keep this power as constant, if this force is increasing, the velocity must be decreasing, which means that these are inversely proportional. These must be inversely proportional to each other. So you just need to find out which one is showing the inversely proportionality. The option A is the correct answer. So at a low speed, the force will be higher. At high speed, the force would be lower, which means that inversely proportional. So option A is the answer. Question number 17. A book is released from rest and slides a distance x down a straight slope. The slope is at an angle theta to the horizontal. The slope is frictionless and air resistance is negligible. The acceleration of a free fall is g. Which expression gives the final speed of the block? So you need to find out the final speed, and the value is given as the block is released from rest, which means that u is equal to 0, and the angle is also given. So the reason for this block to slide is the weight of this block, right? So the force acting on it is the weight, which is at an angle theta to the normal, right? So this is theta. It is moving downward. So this is the line, right? This is the the force direction that you need to find out, right? Here the formula that you could use is v square is equal to u square plus 2as. So the acceleration here in this case would be g, but not only g, because g is acting on this this direction, right? But the acceleration, the movement is in this direction. So the whole g is not contributing to this, but a part of g, right? So you need to find out this this g component, right? So the acceleration here, it is g, since weight is mg value. Here the component will be g sine theta. You need to know the resolving vectors. G sine theta would be the component along its motion, right? So V square is equal to U square, which is 0, plus 2 times G sine theta times the distance. So distance along this direction is x, which is given, right? So V is equal to root of 2gx sine theta. So the option B is the answer. Question number 18. What is meant by spring constant of a spring? In the case of spring, the formula that we know is the formula for the Hooke's law, which is equal to F is equal to Kx. So the K is what we call the spring constant, right? So K is equal to F divided by X. Just rearrange this, you will get, which means that the force per extension, unit extension. So the option D is the answer. Question number 19. A child holds a thin metal wire that is attached to a kite. The graph shows how the extension of the wire varies with its tension. A gust of wind increases the tension from 100 Newton to 150 Newton. What is the change in the elastic potential energy of the wire caused by the gust of wind? The formula for the elastic potential energy is half Fx. Okay, so here in this case, the first condition is the 100 Newton and then it is changing into 150. You need to find out this difference. So at the first stage, the elastic potential energy is half times the force. The force acting on it is, of course, the tension, right? 100 multiplied by the extension. Just find out the corresponding extension, but just be careful, it is given in millimeter. So you need to convert this 0.3 millimeter into meter, which is equal to 0.015 joules. Okay, so in the second condition, when it is increased and reached to 150 Newton, the elastic potential energy is 0.5 times 150 multiplied by 0.45 in terms of meter. So you'll be getting the value as 0.03375. Just find out the difference between the elastic potential energies. The change in the elastic potential energy would be 0.01875. Just change in terms of millijoules. This is in terms of joules, right? So in terms of millijoules, it will be 18.75 times 10 to the power minus 3 joules, which is equal to 18.75 millijoules, which means that the option B is the correct answer. Question number 20. A microphone detects a sound wave. The microphone is connected to a cathode ray oscilloscope CRO. The shape of the trace on the screen of the CRO is shown. Which property of the sound wave can be determined by using only the measurement of a horizontal distance on the screen and the value of a control setting of the CRO? So here, in the case of CRO, the this horizontal line or the distance is representing the time. Okay, the vertical is representing the amplitude in terms of voltage. Okay, because it's converted that wave, even it's also sound wave or light wave, whatever it be, it is converted into electrical signals and it is shown on this screen. That's how this CRO works, right? So the amplitude will be in terms of voltage per division. So on the horizontal axis, it will be times per divisions. Okay, so here if you're multiplying the horizontal distance, which means that the time or the number of divisions for one wave. Okay, if you're choosing the one wave, how many divisions are there, that divisions multiplied by the value that is you have given on this control setting for the time per division. If you're multiplying these two, you'll be getting the time taken for that for that wave, which is what we call the period. So this is a CRO representation. So here this x-axis is representing the time. So here it is the time per division value, as I am just changing this times per division value. Okay, this horizontal line is what changes, not the vertical. If I am just changing the voltage per division, then only that amplitude changes. Okay, that's why I told you the horizontal line is representing the times per division and the vertical line is representing the voltage per division. Okay, so in this video I've just discussed the first 20 questions of this paper 1-2 of multiple choice P1. In the coming video I'll be discussing the second part, okay, the rest of the 20 questions. Thank you.